Hi, Math 3 students. So this video is to try and help you prepare for the 1.4 to 1.5 quiz we are going to have. So I'm going to go ahead and go through some of these problems and feel free to skip ahead if you got the answers right and you feel good. Feel free to skip ahead to whichever ones you need help with. So for these first ones, it says state if the given functions are inverses. So basically you should remember that if something is an inverse, when you plug that function into the other function, you should get x out. So basically, if for number one, if I do g of f of n and I get n out, and I do f of g of n and I get n out, those guys are inverses. If I get anything else, they are not inverses. So let's go ahead first. We will find g of f of n. So I'm going to go ahead and plug this into here. So I am going to get 4 times negative 2n minus 4 all over 3. So then I need to distribute this. And I get negative 8n minus 8 all over 3. So just from right here, you should be able to tell that these guys are not inverses. I can't really simplify this anymore. I mean, I could write it, as like negative 8n over 3 minus 8 over 3, but that's not going to help me. So if g of f of n equals this, they are not inverses. All right. Again, if I had gotten n as my answer, then I would do the other one and make sure I was good to go. All right. So now let's go ahead here. We're going to do g of f of n. So I'm going to go ahead and take f of n and plug it into here. So I get the third root of, and remember, I am plugging this guy in for where I see an n. So I have this negative out in front first, and then I'm going to plug in the green thing. So I have the negative 1 minus n to the power of 3, and then I have a minus 1. So to kind of see where things went, my green thing went right in there. All right. So now I can go ahead and kind of simplify what is in my radical here. I'm going to distribute this negative. So I get positive 1 plus n cubed minus 1. These ones cancel. And I get cube root of n cubed, which gives me n. Okay, well this checks out. Now let's go double check and make sure that f of g of n equals n. And if it does, then it looks like I'm good to go here. So this time, I have to plug g of n into f of n. So I'm going to start out with negative 1 minus, and then I've got to plug in my green guy. So I get the cube root of negative n minus 1 cubed. So again, that green thing went right in there inside of the n cubed. Oh, whoopsies. So then the cube cancels out my cube root, so I get negative 1 minus, and then in parentheses, I got negative n minus 1, because that just popped out of that radical. So then I got to go ahead and distribute this, and I got negative 1 plus n plus 1, which gives me n. All right, so you will need to show these steps on your quiz, that you know how to, plug this in and see if they're inverses. All right, so now let's try number 3. We're going to do f of h of x. So I'm going to go ahead and take h of x and plug it in to f of x. So I get the cube root of x plus 2 cubed plus 1. And then on the inside of this radical, I have a minus 1. And then on the outside, I have a minus 2. All right. So let's go ahead and we actually, we have a lot of work to do here. So this guy here, hold on. Oh, okay, sorry. I was looking at this wrong. I apologize. So these guys cancel. So I get cube root of x plus 2 cubed. This actually isn't as much work as I thought it was. And then the cube root cancels out with this. So I get x plus 2 minus 2, and I get x out. So this is looking good so far to be inverses. Let's keep working and, check the other guy. So, oh, cool. We are going to take f of x and plug it into h of x. All right. So I get open, or here, I'll say h of f of x equals, and I'm going to do open parenthesis, and then I'm going to, within parentheses, plug this ugly guy in. So I'm going to do cube root of x minus 1 minus 2, and then I have to do a plus 2 cubed plus 1. And you're probably like, oh my gosh, where did this stuff come from? Well, this guy got put in right here. All right. And then your h of x was all this other stuff. So your h of x was this plus 2 cubed plus 1. So that came from here. So hopefully you can kind of see where those parts came from. And then what's going to happen is these guys cancel out, and I get the cube root of x minus 1 cubed plus 1. These guys cancel, right? Cube root and a cube. I get x minus 1 plus 1. I get x. So yes, they are inverses. All right. All right, we got one more of these. So for number 4, I'm going to go ahead and take this and plug it into here. So we will do h of f of x first. So I get 4 over, and this ugly mess is pretty horrendous, over 1 over x minus 1 minus 2 plus 2. All right. So these guys cancel, and I am left with 4 over 1 over x minus 1. So if you recall, when you divide fractions, you take the second fraction, you flip it, and you multiply. So I've got 1 times x minus 1 over 1. So I flipped this guy. So the purple went on top, orange went on the bottom. So then I go ahead, I end up with x minus 1. So it's looking like these are not inverses, right? I would have had to end up with just an x, and I got x minus 1. So they are not inverses. All right. So let's find the inverse of each function. So the first, our 0 step, right, is to write y equals negative 2 all over x plus 2. And then we got to switch them. So we get x equals negative 2 over y plus 2. So now I need to go ahead and start solving here. So what I'm going to do is I'm going to move this 2 over. So I get x minus 2 equals negative 2 over y. All right. Now this is where I think I'm going to lose a lot of you, but I need to get this y by itself. So one thing you could think about here, you could always make anything a fraction by putting it over 1. You could just cross multiply. So I get y times x minus 2 equals negative 2. I just cross multiplied there. All right. And again, I'm trying to get my y by itself. Well, the y is being multiplied by x minus 2. Divide both sides by x minus 2. I get that y is equal to negative 2 all over x minus 2. So my f inverse of x is equal to negative 2 all over x minus 2. That was a hard one. All right, next one. Y equals 1/8 n minus 29 over 8. So we can switch our n and our y. Same thing as x and y. We're still solving for y here. All right. Let's see. So I'm kind of looking at this, and I'm going to be honest, kind of how I want to write this, just for simplicity's sake. They've got the same denominator. I want to write them all over the same denominator. So basically I have y minus 29 all over 8. So then I'm going to go ahead and multiply both sides by 8. So I get 8n equals y minus 29. Add 29, and I get 8n plus 29 equals y. So I get f inverse of x equals 8n plus 29. Now, let's say you watched me do this 8 thing and you were like, what the heck is going on? What you could do, I'm going to go ahead and show you how you could do it without knowing to get a common denominator. So let's say we were at this step here, okay? And we have 1/8y minus 29 over 8. So a lot of you guys probably looked at this and you're like, well, I want to add 29 over 8 to both sides, which is fine. You can do that. So I get n plus 29 over 8 equals 1/8 y. And then hopefully you guys remember that you have to multiply by the reciprocal of this, which would be 8 over 1, or just 8. Okay, and you distribute, and I get 8n, and then if you do 8 times 29 over 8, you get 29, which is the same thing. All right, so you should get the same answer no matter how you solve it. So hopefully that cleared up any confusion you had while watching me do that. All right, next one. So I'm going to go ahead and flip-flop these. So I get y equals -2 times x minus 3 cubed. So then I get x equals -2 y minus 3 cubed. So I'm looking at this and I'm like, all right, I need to get this y by itself. So a lot of you guys are going to want to cube it first. You cannot cube it first, and you cannot cube it first because of this 2 here. You got to get rid of this -2. So you're going to divide both sides by -2. So I get x over -2 equals y minus 3 raised to the third power. Now that that third power is pretty much by itself, all right, you could go ahead and take the square, or the cube root, I apologize, of both sides. All right. So now I've got the cube root of x over -2 equals y minus 3. All right. And then I'm going to go ahead and add 3 to both sides. So I got the cube root of x all over -2 plus 3. Now, if you look on the answer key, their answer is a little bit different. Don't worry about it. Basically, what they did is they kind of rationalized this denominator. I would not expect you to know how to do that, and I would accept this as an answer. So if you're looking at the answer key, don't be stressing about it. This is what you are looking for here. If you're able to figure out how to get the answer from the answer key, more power to you. But I feel like if I do that, everyone's going to hate me and be very confused. All right, number 8. Y equals -2 all over x plus 2. So let's rewrite that. We get -2 all over y plus 2. So I'm looking at this, and I do not like having my variable that I have to solve for in the denominator. So again, I'm going to do that cross multiplication thing. You can turn that x into an x over 1, and you cross multiply. Now keep in mind, remember when we cross multiplied, where was it? Up here. Notice how I put the binomial. Binomial means 2 terms into parentheses. We're going to do the same thing here. This needs to go into parentheses. So we're going to get x times y plus 2 equals -2. I don't know why my 2's look like h's today. So then I'm going to go ahead. You could distribute the x, but honestly, that's probably not the best option here. You're going to divide by, I would divide by x. So then you get y plus 2 equals -2 all over x. And then you subtract 2, and you get y equals -2 all over x minus 2. And that's what they have on the answer key. Technically, if you got, let's see, if you had distributed that x, which really isn't the end of the world, you'd have what? X, let's say you distributed that x and you didn't know any better. You did xy plus 2x equals -2. You can solve that as well. You would do minus 2x, and you get xy equals -2x minus 2. And then you would have to divide both sides by x, which gives you -2x over x minus 2 over x, which conveniently gives us -2 minus 2 over x, which is the same thing with that. All right? So if you did it that way, you should still get the same answer. So there's different ways to solve these. It's not just one way. So keep working through these. All right, I'm gonna start skipping step 0 just for time's sake in this video. Miss Slattery's got to get to bed soon. All right. So looking at this one, this will probably be another one where the answer key does not match what we get, which is okay. It's equivalent, just doesn't match. So I'm going to go ahead and divide by 2. So I get x over 2 equals y plus 3 cubed. So I'm going to take the cube root of both sides, and I get cube root of x over 2 equals y plus 3. And then I'm going to go ahead and subtract 3 on both sides. So I get that y is equal to the cube root of x over 2 minus 3. which is this, which we would write as f inverse of x equals the cube root of x over 2 minus 3. Again, the answer key is going to look different for that one. All right. Let's see. I feel like I probably don't need to do the rest of these. How about I'll do 10 and 13. All right. So for 10, again, I'm going to do x equals y to the 5th plus 1. I need to get y by itself. Do not fifth root this yet. You have to have that root by itself, or the power by itself, and not everything on the right-hand side is being raised to the 5th power. Only the y is. So I got to get that by itself. I get x minus 1 equals y to the 5th. Fifth root it, and I get 5th root of x minus 1 equals y. And that's it. F inverse of x equals the 5th root of x minus 1. And then I've done a lot of examples like these so far. So let's go ahead and try 13. So we can go ahead and do x equals the 3rd root of negative x minus 2. Oh, negative y. Sorry, I was skipping step 0 there. All over 2. So in this case, you do want to cube right away. And the reason you can cube right away is because literally this entire side is in the cube root. Okay, so I'm going to cube both sides. And I get x cubed equals negative y minus 2 all over 2. Then I can go ahead and multiply both sides by 2. And I get 2x cubed equals negative y minus 2. Then I'm going to add 2 to both sides. And I get 2x cubed plus 2 equals negative y divided by negative 1. So you should end up with negative 2x cubed minus 2. I just divided each term by 2. So hopefully that has helped. Now for these next ones, basically what you got to do is you first got to graph these functions. Let's say, hopefully you remember how to graph lines. If you did forget, no big deal. Make an XY chart, okay? Plug in like negative 2, negative 1, 0, 1, and 2. And you could graph it that way. I'm fine with that. I don't really care. And actually, that might be more helpful in terms of flip-flopping the signs. So, whatever works for you, go ahead and do it. So I guess, we'll go ahead and we'll just do it this way to be safe, I guess. So we end up with negative 1/4 times negative 2, which is going to give us 2 over 4, which is 0.5. All right. Then I get negative 1, so I have negative 1 over 4. Times negative 1, which gives me 1/4 or 0.25. Now, when you're graphing, honestly, I would recommend decimals. I'm usually not a huge fan of decimals, but definitely when you're graphing, it's kind of, to me, it's not as useful. If I get like 13/5, I don't know what that is. So you want to go ahead and just get the decimal equivalent. It makes things easier. So you plug this in. Look I just said use a decimal and I gave it as a fraction. And then that would be negative 0.5. All right. So then we could go ahead and plot the original function. So what I'm doing right now is I am just plotting the original function. All right. So I get negative 2, 0.5, negative 1, 0.25, 0, 0, 1, negative 0.25, and 2, negative 0.5. All right, so it's going to look something like that. You can kind of extend that. So that is our original function. Hopefully that looks okay. So now, when we are doing the inverse, and I would recommend graphing the inverse in a different color. If you have a different color, make your life easier. You have 0.5, negative 2, 0.25, negative 1, 0, 0, negative 0.251, and negative 0.52. All right, so we have 0.5, we go to negative 2, 0.25, we go to negative 1, 0, 0, then negative 0.25, we go to 1, and then negative 0.5, we go to 2. So this is our inverse. All right, if you're good with, graphing lines, you don't necessarily have to make a table, but that actually might be a little bit more helpful in this scenario because all you're really trying to do is flip the points. So let's go ahead. I'll do one more of these. So I guess one more. It's the last one. So we'll go ahead and make our original in red again. So we have x and y. So again, we'll just plot in 0, -1, -2, 1, and 2. I just randomly pick these points. Typically I shouldn't say typically, but a lot of the times if you plug in x values that are close to the y-axis on like nice problems, they'll graph nicely. So I'm just picking safe numbers here. So I'm going to do 3 times -2 plus 1. So we have -6 plus 1, which is going to give us a -5. -1, we have 3 times -1 plus 1, which gives us a -3 plus 1, which is going to give us a -2. We plug in 0, we should get 1. We plug in 1, we should get 4, because it's going to be 3 times 1 plus 1. We plug in 2, we should get 6. Did I do that wrong? We should get 7. I'm like, that doesn't seem right. Sorry, we should get 7. Because it's 6 plus 1. I did 3 plus 2. It's getting late, guys. All right. So then we're going to go ahead and we'll plot the original function. So and this one's actually off the chart a little bit. No big deal. And we plot that. So this is our original function. Now let's go ahead and plot our inverse. So you might want to label this actually f inverse of x. And we get x, y, and we flip-flop, so we get -5, -2, -2, -1, 1, 0, 4, 1, and 7, 2. So let's go ahead and plot this. -5, -2, -2, -1, 1, 0, 4, 1, and that other guy's off, so don't worry about him. And that is our inverse. Now again, you should be able to tell that these are inverses because they reflect over the line y equals x. And obviously the same thing is true here.